So in this little tutorial, I want to go over why I use Blender in conjunction with Fusion 360 and why that's such a powerful combination. In Fusion 360, you can create solid bodies from T-Splines, which you can create from a quad mesh. But the abilities to create complicated meshes are very limited in Fusion 360. On the other hand, in Blender, you can create really complex quad meshes like this gyroid here. But you can create solid bodies that you just add mechanical features to. So that makes that a great combination. So the user in this thread actually has a gyroid, and it's a quad mesh. He's imported it in Fusion 360 and tried to thicken it in the patch environment. And that thickening actually failed. And the reason for that is the surface created by the T-spline is very complex, and the patch thickening, or surface offset for that matter, tries to create a precise offset from that surface. And because this surface is so complex, it can't do it and it fails. So then the next best option is to use the thickening feature in the T-spline environment. And unfortunately, that creates these, well, they're not really distorted, but the matter of fact is that the wall thickness here is very inconsistent. And the reason for that is that there is not enough geometry. This mesh, before it's imported, needs to be subdivided. Now you can subdivide it in Fusion 360. It would take for ages because it's a very complicated mesh. But it's also a flat subdivision. It's not a Catmull-Clark subdivision. You can do that, however, in Blender. So I'm going to show how you can actually create a thickened gyroid in combination with Fusion 360 and Blender. So what actually is a gyroid? So the first thing is this is a mathematically describable surface, and the mesh design method that's used to design this is just an approximation of this. But it's a very complicated surface here, and if you understand all that stuff that Wikipedia tells you, that's great. I can't say that I do. What I do understand, there's also a Blender tutorial that describes how to really create such a gyroid. And this is on the right side here. That's sort of similar to the end product that we'll see. So let me go into Blender first. And this is a startup screen with the default cube. I delete this. And I don't need the tool shelf right now. I hide this. And I'm going to import that OBJ file that the user has already made available in the thread. So there it is. Of course it is too big. So I hit Q and I shift to perspective mode, to orthogonal mode. And I have deselected everything and then right click to select this cube-like structure. And we can see there are quite a few faces in here. It looks a little bit structureless, but we get to that in a moment. It's a thin surface constructed from quad faces, so to speak. So, and as you can see here, I'm using the pie menu that's available in Blender. So then the next thing I'm going to do is I'm going to actually, as I said earlier, this needs to be subdivided. And let me widen this a little bit and turn on wire view mode. And here we see the face borders that it's created from. And hopefully that makes that a little bit clear what's the structure of this is. So I said it needs to be subdivided. So the first thing I'm going to do, I'm going to here go to the modifier stack and add a subdivision surface. And one level. I can increase the levels as I like. And I can also switch it from Catmull-Clark to simple. And the difference between the two is that simple would basically just subdivide the flat faces similar to what you would do in Fusion 360. But if you switch to Catmull-Clark, it's smooth according to that Catmull-Clark algorithm. And that's precisely what we want. So now we have a higher subdivision. So that would present us with enough geometry to thicken this. Now, you could probably go ahead and export this into Fusion 360 and convert it into a surface. But the likelihood is that also this would not thicken as a surface in the patch environment. I haven't tried this out, but chances are it fails. So the next thing I'm going to do here in Blender is I'm going to apply a solidify modifier. And what that does is basically works like a thickening. And I can increase the thickness. So before I do that, I'm going to switch, and the units are already set to millimeters. That's good. I'll go back to my modifier stack here and increase the thickness to 10. So now it's 10 millimeters thick. That means that's the distance between the T-spline faces. That doesn't necessarily mean if you don't have enough geometry in your mesh, then the thickness of the final body won't be very consistent. It will be fairly consistent with the surface density now. So that provides us with a higher resolution smooth mesh. But the problem is, of course, if I import this into Fusion 360, these edges here, they won't even have a little fillet on it. They will be completely rounded. So the next thing I'm going to do, I'm going to apply another modifier, and that would be the bevel modifier. And the bevel modifier bevels every single edge in default. So what I need to change it to is actually the limit method, and that'll be angle. And faces that are angled, and this is, I just showed this arbitrarily or as a guess. So all faces that have an angle between the faces of 75 degrees or bigger will be beveled. So that limits this to the edges here. And I'm going to turn clamp override off and loop slide off, and then I'm going to change this to, say, 2 millimeters. All right, so now we have a 2 millimeter bevel on our mesh, soon to become a T-spline. I'm going to make that 1 millimeter, so we have a very small crisp fillet here once we export this. Now, this is basically the mesh that we are going to export into Fusion 360 or into an OBJ and then import into Fusion 360. Now, I'm going to increase my clip cube here so I don't have these artifacts here. So that should be okay. But we may want to see how this looks like once we go into Blender. So I'm going to turn the wire view mode off here and go back to my modifier stack, and I'm going to apply another modifier, another subdivision surface modifier. So we can see this, that makes this very fine and yet finer. And I switch this to smooth shading. And this is basically how smooth this would look when imported into Fusion 360. So maybe we want to give that a little bit more of a shiny surface. I'm going to turn on Madcap and pick something a little bit more shiny. And this would be the final object. So as I said earlier, I don't want this final subdivision surface modifier, because if we look up here at top, we already have 1.5 million faces. So Fusion would choke to death on 1.5 million faces. We're just going to delete this. We don't really need it. And we're going to change the shading back to flat, so we can see all the polygons that we're going to export. So right now, that's about 97,000 faces. And that's quad faces, right? So we can now go ahead and export it. I right-click to select it, the object, select export, export, and wavefront object. I also usually pick selection only if you have a Blender file with more than one object, but you only want to export one of these objects, then select it in the viewport and then select selection only here. In this particular case, we do want to apply the modifiers. We don't want to write materials. That would only create an additional file with the extension MLT. But Fusion 360 doesn't read that anyway, so we don't need it. And then we can hit export OBJ, and we have an OBJ file. I've done that already, so we don't need to do that anymore. And I want to emphasize this one more time. None of this is actually possible in Fusion 360. You couldn't even design this mesh properly in Fusion 360. You would need something like a different modifier. In Blender, you have, for example, you have another modifier, the array modifier, which is very, very powerful. That would help you to create smaller meshes and array them and merge them together into one larger mesh. So that's one other reason why Blender makes a tremendous combination with Fusion 360. Anyway, let's go to Fusion 360. There's a new file, and we need to turn off the design history in order to import a mesh. We're going to import this mesh, and I had exported this earlier, and here it is. And there's our mesh, right? That's how it looks like. And I will convert this into a T-spline. And because I'm recording, that may take longer than 1.5 minutes, but when I tried this earlier, it was 1.5 minutes on my MacBook Pro here. So that's our T-spline. Perfectly fine T-spline. And now we can convert that T-spline into a B-rib. So that's our solid body here. So let's quickly see how that would look like in the render environment. That'll take a moment. Apply something nice and shiny. Maybe turn down the environment and pick a different environment. And there we have a shiny gyroid thickened to perfection.